How are you, my student? Welcome to our lesson today. My name is Purity Anzelimo. Our topic for today is integration. So our subtopic, definite integrals. That is our subtopic for our today's lesson, definite integrals. During our previous lesson, we considered cases whereby we have been given the following, whereby we are told find or evaluate, find the following, find. We've been given, for example, we've been given this, and maybe we have been given x squared plus 2 dx, and we are told to find that. And we say that this sign, which is an elongated s, we say that it simply refers to integrate. It means integrate this. So we are integrating this with respect to x. So you can see in this case, we say that in this case, when we find our answer, maybe we can move ahead and find that we are integrating x squared plus 2 with respect to x. So in this case, when we integrate this, we said when we are integrating, we add 1 to the power, and then we divide by the new power. So in this case, we have x squared plus 1 divided by the new power, which is 2 plus 1, that is 3. Then plus, here we have our 2. Our x here is raised to power 0. So we have x raised to power 0 because a number raised to power 0 is 1. So we come and add 1 to the power, then we divide by the new power, which will be 0 plus 1, that is 1. Then we add a constant c. So in this case, we are going to get this as x cubed all over 3 plus 2x, then plus c. Now in this case, we can see that we have the constant. The constant is still there. We still have the constant in our integral or in the answer that we are getting. Therefore, meaning that whatever we are integrating, when we have such and we do not have the limit, then we say that this is an indefinite. This is an indefinite integral. It is an indefinite integral. We do not have the limits, and therefore in our answer, we still have our constant c, which is not still solved. So this is what we call an indefinite integral. And in our lesson today, we are going to look at definite integral. And I would like you to consider this so that you can be able to know what we mean by a definite integral. Now, if we have the same here, the same function here, the gradient function x squared plus 2, in this case, we have it this way. We have, maybe here is 0, and we have 1. We have the limits. These ones, we call them the limits, 0 to 1. When we have the limits and we have the same function, x squared plus 2, then dx, in this case, it simply means that we are finding this integral, but now we have the limits. We have the limits, that is from limits from 0 to 1, from 0 to 1. When we have a function whereby it has the limits specified, like from 0 to 1, from 9 to 10, from -1 to 7, when we have such limits, then we say that we have a definite integral. So we are going to get a definite integral, and like in this whereby we are getting an indefinite integral because the limits are not specified. So in this we are going to get a definite integral. Definite integral. Now with this one, we use it now to determine the exact area under a curve. So we use this, that is the definite integral. We can use it when we require the definite, or when we require the exact area of the area under a curve. When we have been given the function when we require the exact area under the curve, then we can use this because we have the limits 0 to 1. So the general equation for this, when we can talk of from A to B, and then we have our function. Let's say we have y, this is our gradient function, and we are integrating with respect to x. This simply refers to our A and B are our limits. A is called the lower limit. A is the lower limit, and B is called the upper limit. This is the upper limit. So when we have this, we are simply supposed to come and get the integral of y under the limits with respect to x under the limits A to B. So in this one, we are supposed to come and find the integral of y with respect to x for the limits A to B. So that's what the question is asking when we are given such. So the limits we have A to B, our A is called the lower limit and B is called the upper limit. So in this, we are simply being asked to integrate this, or to find the integral of y with respect to x for the limits A to B. So in this case, we are going to get an exact value. We are going to get an exact value in this, unlike in the indefinite integral, whereby we got this. This is not exact, the exact value. So we are going to solve the same x squared plus 2, which is our gradient function, but now we are going to have these limits from 0 to 1. And in this case, let's see what we are going to get. We have from 0 to 1, so we are finding this, and we will have the limits 0 to 1, and our gradient function is x squared plus 2, and we are integrating with respect to x. So in this case, this is the procedure that we follow when we want to get the integral. That is whereby we've been given the limits, or when we want to find a definite integral. The first thing is to find the integral. Or simply integrate whatever is given. The first thing is to integrate. That's the first step. Then after integrating, now we need to get the integral using the lower limit, and then the integral using the upper limit. So we find the integral using the lower, we can start with the lower limit, then find again the integral, in this case using the upper limit. We'll move step by step. So the first thing is to find the integral, to integrate this. Then after integrating, we need now to find the integral using the lower limit. Again, we come and find the integral using the upper limit. And finally, to get the answer for this, we subtract the integral. Using the lower limit from the integral using the upper limit. And whatever we are going to get is now the exact value. So the first thing, to integrate. The second one, we find the integral using the lower limit. Then we find the integral using the upper limit. Then we subtract the integral using the lower limit from the integral using the upper limit. And I would like us to solve this one. We follow the the 4 steps that I've given so that we can find the integral for this. So we have been given 0 to 1, and then we have our gradient function x squared plus 2. We integrate with respect to x. So in this case, the first thing is we integrate this. So we are going to have from 0 to 1, and we are now integrating. So first, we don't consider this because we want first to integrate. So this simply means integrate x squared plus 2 dx. So we are going to have this as x. We have 2 plus 1 divided by 3, then plus 2, x raised to power 0 plus 1 all over 1, and then plus the constant. So this one will be x raised to power 3 over 3 plus 2x, then plus c. So that's the first step. So we have integrated. So we have the integral for this. Then number 2, we find the integral using the lower limit. Now in this case now, with the lower limit, we want now to have, we have from 0 to 1. And this is our lower. This is the lower limit. Now in this case, we have this, these are the values of x. The x is from 0 to 1. X is from 0 to 1. And therefore, using the lower limit, and using the lower limit in our case, x is equal to 0. So we come again and get our integral. And now substitute x with 0. So we are going to have, therefore, we have it this way. We'll have, therefore, x cubed all over 3 plus 2x, then plus c. And where we have x, and therefore now we substitute x with 0. So in our case here, we are going to have x raised to power 3, and our x is 0. So we have 0 power 3 all over 3 plus 2. We are multiplying by 0, then plus the constant c. So in this case, we are going to have the following. That is now for the lower limit. For the lower limit, this is what we are going to have. For the lower limit, therefore, we have 0 all over 3, that is 0, plus 2 times 0, which is 0, plus c. So in our case here, we have c. That is for the using the lower limit. Then again, now we need to come and use using the upper limit, whereby in our case, with the upper limit, our x is equal to 1. So in this case, again, we need to have that integral, that is x cubed all over 3 plus 2x plus c. Where we have x, we substitute with 1. So this is going to be 1 cubed all over 3, 1 cubed divided by 3, then plus 2 multiplied by 1 plus c. So we have 1 cubed, which is 1. So this becomes 1 over 3 plus 2, then plus c. So in our case here, we have 1 over 3 plus 2. That will be 2, 1 over 3, then plus c. So that's what we have using the upper limit. Then we have now the last step. Subtract the integral using the lower limit from the integral using the upper limit. So we take the integral using the upper limit. We subtract the integral using the lower limit. So that's the last step. So in our case, we have from using the upper limit, which is 2 and then plus c. Then we subtract the answer using now the lower limit, which is minus c. So therefore, this becomes 2 and then plus c minus c. So this constant plus c minus c, this will cancel, and we get our answer as 2 and then. And therefore, we can say that from 0 to 1, when we solve this function x squared plus 3, with respect to x, we end up getting 2 and then, which is an exact value. It is an exact value, and therefore we can say that our integral is a definite integral. So this is what we are going to have. And maybe we can make a summary of what I've just explained, whereby in case therefore you have the following definite integral. You've been told to find this. It is from 0 to 1, and you have now your x squared. Sorry, this was supposed to be plus 2. This is plus 2. The equation that we had, x squared plus 2. So when we have x squared plus 2, you are integrating with respect to x. It simply means that we find the integral for this x squared plus 2 with respect to x, whereby we are going to get this is x cubed all over 3 plus 2x plus c, and then now we put the limits. First, we substitute with 0, and then we substitute with 1. So when you substitute with 0, that's the time now we are getting. So in this case, we are going to have, when we want now to find the exact value, we are subtracting the integral when the limit is the upper one. We subtract now when the limit is the lower limit. So in this case, therefore, it simply means from this we have, therefore, our x is 1 cubed all over 3 plus 2. Our x is 1 plus c. Then all of that minus, when x is 0, we have 0 cubed all over 3 plus 2 multiplied by 0 plus c. So you can see in this we have 1 over 3 plus 2 plus c, then minus 0 over 3, that is 0 plus 0 plus c. So in our case here, we need to open the brackets. We get 1 over 3 plus 2 plus c, then minus, this is 0, so minus c. So c and c will cancel. So we have a third plus 2, which will give us 2 and a third. And that is our answer. So when we have a definite integral, we are going to get an exact answer. Like in this one, we have 2 and a third. But for an indefinite integral, you can see that we were getting now the answer with a constant. But for this, the constant will cancel out, as you can see, because we are subtracting this minus when the limit is 0. And that is the lower limit, 0. When we subtract, you can see that c and c will cancel. That is the constant. So even there is no need. When you are finding this, that is for a definite integral, you don't even require to put the constant. Because even if you make this constant, it will have no effect. Because at long last, the constant will cancel out. This constant c, the constant cancels out. And therefore, you may not even need to write it when you are finding a definite integral. So I want us to do more examples on this for you to understand it better. Can do the following. Evaluate the definite integrals below. Evaluate the definite integrals below. Evaluate the definite integrals. So we can start with the first one, number A, whereby we have the following. We have this from 1 to 2. Then we have 4x plus 3. And this is with respect to x. So we find that one. We move step by step. The first thing we've said is to integrate. So we integrate this. We integrate 4x plus 3 with respect to x. So in this case, we are going to have 4x. X is raised to power 1. We add 1 to the power. We divide by the new power. Then plus 3. In our case here, x is raised to power 0. So we add 1. Then we divide by the new power. Then we have plus c. So in this case, we are going to have 4 divided by 2. That is 2x squared. Then plus 3x plus c. So that is what we get after integrating. Then after that, therefore, this simply means now we want to find with the limits. We have 2x squared plus 3x plus c. And we have the limits from 1 to 2. And therefore, we substitute x with 2. Then again, we'll substitute x with 1 and subtract. So in that again, this is what you are going to have. So in the first case, you can therefore write this therefore as, in the first one, we have 2 multiplied by x. Our x is 2, the upper limit, 2 squared, then plus 3, our x is again 2, then plus c. That's what we have. Then minus, when x is 1 now, we are going to have 2 into bracket x is 1 squared, then plus 3x, 3 multiplied by x, which is 1, then plus c. So in this, therefore, we are going to have this as 2 squared, that is 4. So in this case, we are going to have this, therefore, as 4 times 2, that is 8, then plus 6, then plus c. So we have the first part. Then minus, when using now the lower limit. So we have this. This is for that. So we have 1 squared, 1 times 2, we have 2, then plus 3 plus c. So therefore, we get 8 plus 6, we get 14, 14 plus c, then minus 2 plus 3, that is 5, then plus c. So now we can open the bracket. So we'll have 14 plus c, minus, this minus will affect 5 and c, so minus 5, then minus c. So this c and that c will cancel. So we remain with 14 minus 5, whereby we are going to get that as 9. So our answer to that, we are going to get it as 9. So part B, we can do another example for a definite integral where we are told to evaluate. In this case, we've been given the following. The lower limit is 0, the upper limit is 3. Then we've been given the function, the gradient function as 2x squared, and then we are integrating with respect to x. So in this case again, we follow the same procedure. The first thing is to integrate. So we need to integrate this. So we simply come and integrate 2x squared. We do not now include the limits at first. Then we are going to include them later. So in this case, we are going to have therefore 2x squared. We add 1 to the power. We divide by the new power, then plus the constant. So we'll have this as 2x raised to power 3 all over 3, then plus c. So now, after this, now we need to include the limits. So we are finding simply 2x cubed all over 3 plus c, then the limits are from 0 to 3. So we solve when x is 0 and again when x is 3. So in this case, therefore, we are going to have with x 0, we are going to have 2. We have x raised to power 0. Sorry, x is 0 raised to power 3. So we have 0 raised to power 3. Then all over 3, then plus c. Then again now using the other part, we have now with the other part we have 3. So we are subtracting the integral for the lower limit from the upper limit. And therefore we need to start with the upper one, which is 3 in our case. That is the upper. Then we subtract now using the lower. So we are going to have 2. Our x here is 0 raised to power 3 all over 3, then plus c. So we solve that, whereby therefore now we are going to have this as 3 raised to power 3, that is 27. Then we have 27 times 2, then divide by 3. So we have 54 divided by 3, that is equal to 18. So we have 18 plus c, then minus into bracket, this is 0 over 3, 0. So we have 0 plus c. So in this case, therefore, we are going to have this s. We have 18 plus c. We have therefore 18 plus c minus C. So C and C will cancel and we get our answer as 8. So we'll have solved this from 0 to 3, that is 2x squared. Another example for this, we have the following. Part C, we've been given the limits from -1 to 3, and then we have t minus 1 squared dt. And we are told to solve or to evaluate that definite integral. So in this case now, the first thing is to integrate this, that is t minus 1 squared with respect to t. So in this case, we can first expand this. We have t minus 1 squared, t minus 1. So this simply means it is t squared, then t, we have minus t, again minus t, then plus 1. So in this case, we have 2 squared minus 2t, then plus 1. So that is what we are integrating. So we have therefore from -1 to 3, and we have t squared minus 2t, then plus 1 with respect to t. So the first thing is to integrate. So we integrate t squared minus 2t plus 1 with respect to t, and we get the following. So this will be t squared plus 1 all over 3. Then minus, here we have 2t. It is raised to power 1, so plus 1 all over 2. And finally, we have 1t, which is raised to power 0, plus 1 all over 1, then plus our constant c. So we are going to have, therefore, this is t raised to power 3 all over 3, then minus by 2, 1 by 2, 1, so we remain with t squared, then plus, here we have 0 plus 1, that is 1, so we remain with t plus c. Then after that, we need now to include the limits so that we can now evaluate and get the final answer to that. So here we come and now put the limits. So in that, with whatever we've gotten, we have therefore t cubed all over 3 minus t squared plus t plus c. And this, we put this square bracket to show that now we are multiplying with 1, -1, that is when x is -1 and when x is 3. So in our case here, we are therefore get t, our t is 3 in the upper limit, so we'll have 3 cubed all over 3 minus our t, which is 3 squared. Then we have plus t, our t is 3, then plus c. Then we have minus, when now our t is -1. So we have -1 raised to power 3 all over 3, all over 3. Then minus our t squared, and our t is -1, so squared. Then plus t, and our t is -1, and then plus c. Plus c. So that is what we have. Then we solve it. So in this case, we are going to have 3 cubed, that is 27. 27 divided by 3, that is 9. Then minus 3 squared, that is 9. Then plus 3 plus c. Then all of it, we have minus -1 power 3, that is -1 times -1 times -1. So we get -1 over 3. Then minus -1 squared is 1. So we have -1. Then plus minus. So we have -1. Then plus c. So in this case, therefore, we get this is 0. So we have 3 plus c minus we have -1 over 3 minus 1. That is -1 minus 1. We have -2. Then plus c. So again, now we can open the brackets whereby we have 3 plus c. Then we have minus. In this case, now this minus and minus becomes plus 1 over 3. Again, plus 2. Then minus c. So c and c will cancel out. And finally, we have 3 plus 2, that is 5, 5 and a third. And therefore, our answer will be 5 and a third. And therefore, we'll have solved this t squared minus 2t plus 1 with respect to t, and from the limits -1 to 3. Finally, the last example, number D, we can have the following. We are still evaluating the definite integrals, and we require this knowledge in our next lesson, whereby we'll be looking at now the area under the curve. So finally, we have the following. In this case, we have this number D. We have from 1 to 4, and then we have x plus 4, and then we are integrating with respect to x. So we can do that one as the last example. So in this again, the first thing is to integrate. So we integrate x plus 4 with respect to x. In this case, we'll have now x raised to power 1 plus 1 all over 2, then plus 4x raised to power 0 plus 1 all over 1 plus the constant. So here we have x squared over 2 plus 4x, then plus c. Then after that, now we need to remember the limits from 1 to 4. Those are the values of x. And therefore, now we have this square, whereby we have x squared all over 2 plus 4x plus c, and we have the limits from 1 up to 4. So we solve when x is 4, then we subtract the other value when x is 1. So when x is 4, we have 4 squared all over 2 plus 4 multiplied by 4, then plus c. Then all of this minus when x is 1. So we have 1 squared all over 2, then plus 4 multiplied by 1 plus c. So again, we solve this. We have 16 all over 2, that is 8. 8 plus 16, then plus c. Then minus, here we have 1 over 2, then plus 4 plus c. So this one becomes 16 plus 8, that is 24 plus c, minus a half plus 4 is 4 and a half plus c. Then we can open the brackets. We can open the bracket here and see what we are going to get as our final answer. So in this, we are going to have the following. We'll have therefore 24 plus c. Then this negative is affecting both 4 and a half and c. So it will be minus 4 and a half and then minus c. So c and c again will cancel. No wonder I was saying there is no even need of writing it when we have a definite integral. So in this one now we have this minus this, which will be 24. This is 24 minus 4. We have therefore 19 and a half. And therefore that's our final answer, 19 and a half. So I'd like you to do the following. Ensure that you do the following. That is now for the definite integral. So evaluate the following. Evaluate the following definite integrals. Definite integrals. Evaluate the following definite integrals. Part A, you have from 0 to 3, that is x squared with respect to x. Then B, you have from -2 to 0, that is 4x squared. Then you need to multiply by x plus 2, then all of it dx. Then part C, again now from -3 to -1, -3 to -1, we have ax squared plus b. ax squared plus b with respect to x. Then again, number D, you need to evaluate and get the exact value for that. Number D, you've been given the following. This one is from 0 to 2. We have x minus 1, then x minus 2. So you need to solve that first before you integrate. And finally, number E, it's from 1 to 3, and you have 2x minus 1 divided by x cubed dx. So ensure that you evaluate the following definite integrals, and we have seen that for definite integrals there are limits. The lower and the upper, and when you solve any definite integral you get an exact value. So make the difference between this and the indefinite. For the indefinite, we are getting our answer with this C, because like in this case, this is an indefinite integral and that's the answer. But now when we have the definite, when we have those limits, we get an exact answer. So ensure you do this, then we are going to apply the same knowledge in finding the area under a curve. Area under curves. So thank you for being attentive. Let us meet during the next lesson.